All right, so here we go. So let's, and again, even if you're not using Form 3, a lot of times if you look at how some of the Form 3 stuff gets done, since most of these questions or most of these quizzes, question for question, are pretty similar. So you might see something like a philosophy or some sort of an approach to something on Form 3 that might make sense to you on one of the other forms. So I would listen to all of them if your interest is in the stuff making sense. Question 1 kind of requires you to think about how digital sounds are stored in a way. So that can be kind of the confusing part of it. If you break it down, though, it's kind of just like a simple array and loop sort of a question. So we'll get into it. This probably doesn't start making sense until you get down here deeper into the actual question of itself. So it's basically these numbers that are getting stored in here are the volume of different sounds or the amplitude of them. The amplitude. So if a sound is this, right? What's I can't remember what the unit of measure for amplitude is, but if it's at negative 4,000, the actual amplitude is 4,000. So the absolute value is the amplitude itself. So we're going to limit the amplitude, which is something that you guys may have used with like iTunes and Spotify. Both do a thing so that some of the songs you listen to are recorded at different volumes, and it'll normalize them, and that's kind of what this program does. So it just looks through the array. Anything that's greater than limit gets replaced with the limit value. So you have this integer limit that comes in as a parameter, and you just go through the array, and anything that's more than that gets replaced with limit. So the method also keeps track of the number of values that were changed as you did that run, and it'll return the number of values changed when you're done. So you can see that, and you see the result. So basically, it's just a point of completing the method. All these things. If you have questions on how to sort of digest that conceptually, I guess we can go over that, but these are pretty straightforward. So all we do is, I think this looks a little bit easier to go through if we just do it, put it in the Notepad++. Oops. Let's see, there's something, so we'll just do this. So our count holds the number of changes made, right? Because we said we were going to do that, so we need a variable for that. And then we're going to loop through the array samples. So we're going to go from 0 all the way to samples length. And then we're going to ask, is the current sample at position I, is that greater than what we have coming in for limit? And if it is, then we're just going to set samples at I equal to limit, and then we're going to add 1 to the count of the changes we made. The other thing that we have to check, remember, is whether or not it's less than the negative limit, right? So if the absolute value is less than limit, so if it has a higher amplitude away, you think about it in terms of the distance between that and 0, right? If my limit's 4,000 and I have negative 4,500, it has a greater distance from 0 than the 4,000. So it's below, the distance from 0 is greater than our limit. So another way to think about this, and we could have done it like this, we could say if, what you're doing here is saying if the absolute value, I think, if the absolute value of samples at position I is greater than limit, right? Then we would say if samples at position I is less than 0, then we would replace it with we would replace it with a negative version of the limit, right? Otherwise, questions on that one, you guys? So if you think about it in terms of the absolute value, right? We're deciding whether or not the distance from 0 is greater than the limit that we set, right? If the absolute value of the limit that we, or of the current position is greater, right? The distance from 0 is greater, then we figure out if it's positive or negative and just set it to a positive or negative version of the limit. I see some confused faces. Anybody have questions, or that makes a little sense? Okay, let's go to part B. Part B, recorded sound. Okay, so we're trimming the silence from the beginning. All right, so we're just like, if there's a bunch of zeros, so a silence is whenever the amplitude's recorded at 0, right? That would be silence. So if we're trimming silence from the beginning, we just need to loop through the array. Let's go through this, because there's a few different ways to do. Most of your answers will look similar if you've been kind of paying attention. When we've done similar things to this, your algorithm will probably look more like what mine usually is. So basically, we can't modify the size of an array or the type of values that it has. So if we ever want to do any of those things, you know that we're making a new array. And in this case, one of our escape conditions, I think, or our post conditions, is the length of the samples is going to be less, right? Because it doesn't contain as many values anymore. We got rid of some zeros, yeah? So we know that we're going to need to count the number of silences so that we can figure out the new size of the array. So we go, okay, I'm going to have a second array. So I know I'm doing this, new samples, and I know I'm going to have to figure out how many silences I have. And zeros. Yeah. So the reason why this while loop works is because we're starting at 0 and we're stopping as soon as we run into anything that's not 0, right? The loop stop. So it's gonna skip. It's not gonna get to the ones to the silences at the end of the array, right? So we just figure out the number of samples in the beginning, have the array. The new size is going to be the original length of samples, minus the number of zeros, right? So we have so now we know what the length of the new array is. And then we're going to say, so for int I, and really we could start, if we were being smart, we could start at n here, right? Because that's where the actual numbers start. And we could do it that way. Here's what we would do. This is like pretty standard algorithm though. If you go, we're looping through samples instead of, or the new samples array instead of samples. Like we could do it the other way, is where we could go int, we say for int I equals n, I is less than samples length I plus plus. And then we could say, you could say new samples on position I. I guess we'd have to make a new variable there. So we'd have to make a second, like j equals 0. New samples at j equals samples at I. So some of you guys might have done that. And then we go j plus plus. But either way, we have one I that keeps track of the position where we are in one of the arrays, and a second iterator variable that's just n amount higher. So it's up to you how you do it. Either one of these would have been acceptable. Questions on that one? So even if that's one of those questions that conceptually, when you start looking at the sound, it kind of looks confusing at first, but the actual solution, coming up with the solution, is not that big of a deal. Let's see. So now we're going to number 2. App line is defined. So we're looking for a line. And we're trying to, I think it's trying to figure out, is this the one where it's trying to figure out whether or not any, a point is on the line, right? So it'll give you some coordinates and you're figuring out if it's on this line that you've defined. So you take in variable, you have a constructor here, you take in variables. Let's do this. I think the first part of the question asks you, okay, so you're writing the entire class out, right? Okay, so this one's a little tricky. If we read, so assume the following code segment appears on AP line, the code segment shows if the equation, when those x and y values are substituted into the equation, that is a point. I'm gonna figure out how we got. I broke down the mathy stuff, like the mathy part of this one in at home, but for whatever reason it's tricky. Here, basically it becomes, you're doing the same equation here if you multiply a and b by your x and y coordinates. So if you can remember that part, that's what it is. Okay, so if you have x and y, right, the slope of x and y Therefore, if we multiply the points, A plus B. I don't remember the math of this. I completely had the whole thing broken down. With the values of the parameters. Must also include a get slope that calculates and returns the slope of a method. Slope AB divided by B. Yeah, so the slope is ABC. I don't remember how this stuff works anymore. Slope is A divided by B. So if the point X, Y is on the line, then if you put it in basically A divided by B is the slope, and then if you multiply X and Y by A and B, and you add Z and it becomes 0, then then the slope, if you add that between any point on the line and your A and B, is going to be equal. It's going to be equal to the same slope. So just remember that you have to multiply A and B by X and Y. I think the rest of that becomes easy. Are you guys still familiar? What is that, integrated math 2 where you do that? Or is that integrated 1? Probably 1, right? It's basic stuff for you guys. I failed it all, so you guys have questions on that one? I don't think any of the other parts of this are really difficult, right? Because they give you, where is it? They give you most of it. They tell you what to do as far as a class. It says include a constructor that has the 3 integer parameters in that order, right? So if you do that, create instance variables, create parameters. I think it tells you exactly what to return for the scope. Like I said, if you have an if statement in here and the math is wrong, not going to take points off. Okay. The questions basically, can you write, and I think there's one of these on each one of the forms. Can you write a proper constructor and pass data values back and forth between methods, and basically make an entire class work. So one question in each one of these forms is going to ask you, hey, write this entire class out. And as long as you know how the class structure works, I'm not going to grade you on the math part. So do the best you can with that part. Please let me know if you have questions on that one, and I'll go over it with you. The seating chart thing. So we have a class that represents a student object, and then we have a seating chart class that has a 2-dimensional array. So the seats are arranged in like a grid, and you can see that. Well, I'll show you that not on camera. I guess I'll show you the seating chart, but they kind of all show up the same way in like a chart. So our job is to figure out the constructor. So it initializes the seats instance variable. So we have our double array called seats. So we're going to initialize that with the given number of rows and columns. So I think they show, yeah, they have the constructor here, right? So we have a list that's actually a 1D list. And we have the number of rows and columns that are going to be in our seating chart. So we just have to implement that. So that's the first part, is the constructor for that. So pull in rows and columns. We already have, let me see, where'd that go? We already have seats as an instance variable. right? Sometimes it helps to copy and paste stuff in here that we know we're going to use. This would help me if I were taking the test. I'd be like, okay, I remember I got that seats there, and then I'm just going to initialize seats, right, to the exact size that it's supposed to be, right? Then I'm going to, where's the request? And then it says, Constructor, post condition, students appear in the seating chart in the same order as they appear in the student list, starting at seat 00. Seats is filled column by column from student list, followed by empty seats represented by null. So let's see. So for each student in student S, so this is the tricky part, right? Because we have a list of student objects, right? Seats is a list of student objects, and a class student has, let's see, get name. There, I'm assuming it has instance variables. So I'm trying to think where it necessarily have to skim, and then I made stuff. Seats in a classroom. Implementation are not shown. Represents a student. Row and column. Creates a seating chart with a given number of row and columns. Students appear in the seating chart. They appear in the student list. So 4S is equals as R plus plus. If R equals rows 0 C plus plus. Okay, so if you think about this, right, we're looping through the entire, it's a 1D list that we're transferring to rows and columns, right? So each time we add a student to the list, we're gonna set seats at row column, right? And starting at 0. We're gonna start at row column. We're gonna add each student object S to row and column. Then we're gonna go row plus plus. So if I start, say if I have 0, let's say I have something that looks like this for a grid. And so I'm starting at row plus plus, and I'm adding my student object S there, right? And rows and columns. All right, so we're doing columns first, right? So as the rows go up, I'm gonna add that, right? So I put my first S in there, and then I'm adding 1 to the row, right? And I'm gonna check if the rows, if I've reached the final row, and then if not, I'm gonna start the loop again, right? So now my row's 1 higher. So at row 1, I'm gonna put here. So normally when we do these loops, we'd be going this direction. But because of the way the loop works here, I'm actually going plus plus on the rows first, right? So we're actually going column by column. So it's tricky because it tells you to fill it column by column. So you have to read the questions very carefully, right? Because usually we're doing row by row, but we're adding 1 to the columns instead of the rows. So we go row plus plus until we reach the maximum number of rows, which in my case would be row 2, right? So if R has gotten over or has reached the number 2, then we set it back to 0 and we add 1 to the column. So I go over to column 1, but my rows start back at 0 and I go through the loop again. Questions on that one? You guys see how that works? It's just you're basically just flipping the variable that you add 1 to each time. So if you want to go over with that with me in private too, please let me know. And then part B. I guess we're going to, if we did this here, I think I might have 3 people left in here, but you're writing a program that removes students from the class if they have more than 5 absences, I think, right? So yeah, so basically you'd all be gone. So we write remove absent students method, and it removes students who have more than a given number of absences from the seating chart, and it also is going to return the number of students that we removed. So it'll give you an example here, and it'll show things to you visually, right? So we're going to complete that method. So we, at this point, right, it's assuming that we have already initialized and filled our seats, our 2D seats array, right? Remember that it says it's going to return the number of students that we remove, so we're going to have to keep count of that, right? So that tells you right away, I'm going to have to create an instance variable called removed count, or some sort of an instance variable. You know, loop through the seating chart. And this one we can just do it the standard way, even though we added the students the other way. All we're doing, we don't need to keep track of exactly where we are. All we have to do is make sure that we touch each value and count the number of students that have been absent more than 5 times and remove them as we go. What's the other thing that we know that we're going to, what we're going to need to do? We're going to need to figure out how we remove students. Can we change the size of an array? Can we remove positions from an array? No, we cannot. So we need to look at this a little bit more carefully, right? It's saying we're not actually removing objects or things from the array. We're just setting that position to null. So it's going to leave the spot empty. We're just going to set it to null. That's null in that case, I would think, would be the equivalent of like an empty seat in your class at the beginning of the year, and the counselors could see that and say, oh, well, I'm gonna add, I can add more students to that. So if somebody needs an elective or whatever, I can stuff them in there. So like I said, pretty straightforward. We start our remove count, loop through rows, loop through columns. If the value at RC is not null, and remember that seats is filled with student objects, right? And we're assuming that students, and I'm not sure exactly where they go over this, but I think there's a, let's see, class information. Student has a method called get absence count, right? So if we run that, that'll give us the number of absences that the student, so we're going through each object in the array essentially. We're saying how many absences does that have? Let's run this method on it to find out. And then if that's greater than the number of allowed absences, which is our integer parameter, then we're going to set the value at that position to null, and we're going to add 1 to our count of students that we removed. Questions on that one? Okay, let's try the end of this one, which is question 4. So string checker. Ooh, this one's a doozy. This one was super fun. So I think every one of these videos, I'm going to tell you, there's one question on every single form that we have, right? Borderline unfair. That's going to be this one. So if you have because there's just a bunch of, there's multiple methods that you have to keep track of, and you have to set things up in a way that each thing feeds itself. So we have this one. Part A is pretty easy. You create a substring checker that accepts any string, and it will that contains a particular substring. So if the word broccoli is part of the word that you're checking, right, then accept will return true. So we're going to write that class. So substring checker, let's just take a look in Notepad. Copy that. All right. So this one's not too complicated, right? We have the our substring, which is part of the initial object, and then we're initializing that in the constructor. Accept brings in text from the outside, and then we just return that Boolean condition, right? You could also say if text.index of substring is greater than or equal to 0, return true, return false, else return false. You can do that. It's easier because this is a Boolean condition. It's going to return true or false anyway. So you can do it either one of those ways. It doesn't make a ton of difference. That part's pretty simple. Did anybody have problems with that, or you have questions? That one I'm just kind of assuming like that's the easy part of that question, and most people that run into it should know how to do that. Part B is not that. So we can create the superclass checker is pretty basic, or the interface checker is pretty basic. So we can kind of make anything a checker and add a bunch of different functionality. The only thing we have to have is that accept method, right? It has to pull in a string of text and say whether or not it accepts it and return true or false. But you can define whatever the parameters are for that in whatever you write there, and you can make the rest of the class look however you want if you're implementing that. Let's see. So what we need this one to, let's see. Checker's gonna be blah blah blah. So it's just substring checker, the and checker accept method. So we have for example, and checker is a checker that is constructed with two objects of classes that implement the checker interface. And it returns true if both, if it's accepted by both of the checker objects. So basically you have an and checker, right, that has two instance variables that are regular checker objects, or objects of the that implement the interface checker, right? And you just create a constructor and initialize. I think I have this up here. Yeah, so you just create a constructor and initialize, and then you bring in the text, and then it's the same thing as before, but we're checking two separate objects, right? Checker one and checker two, and you just put the and symbol in between. If they're both accepted, then it returns true. Does anybody, this part's a little tricky. Do you guys have questions on that? So essentially, like, let's say we were looking for a certain substring, right? We could say checker one and checker two. When we're running this in like a main method, we could have a main here, right? And in that main, we could create substring checker C equals whatever, right? And then substring checker 2 equals, and we'll give that data, right? So we would do that, and then we could say and checker Z equals new and checker, right? And then we could put C1 and C2, and then we could run the accept method, z.accept, and then we could look for that string, and if both of these strings accept nerds, in other words, if they contain the substring nerds, then that would return true. Question so far? Okay, so then our job, so once we understand what's coming in here, then our job is to just check the two strings, or check the two objects, run accept on them, and make sure they both return true. Part C is, I would have nightmares about running into this one, to be honest. If I ran into this as a free response question on the actual AP exam, whatever year this, I think this was 2013. Good luck, because it's really like kind of frustrating. What it's asking you to do is take, I think it doesn't give a ton of leeway here, or it does. There's, the explanation is not all that great. You're gonna have a not checker, so that's another implementation, and you don't get to see the implementation, but it takes one checker object and an accept method that's only returns true if the object does not accept the string. So what our job is to create consider the following incomplete code. Where's the actual? Using any of the classes, construct a checker that accepts a string only if it doesn't contain either one of the two substrings that it gives you, right? So basically your job's going to be, to combine a bunch of the different checker objects. So if we're going to check for not two things, you have to, you got to have to assume that you use a combination of and checker and the not checker, right? And that's, if you look at solution, as unfair as this is, we're going to use a substring checker, artichokes, and kale. And it's an and checker. And in there, we're putting two new not checkers. You could also put, you could also say checker. You could make these, you can make these not checkers as well, I suppose. I suppose you could put these in there as well, and then just say that. So we could do that as well. You just need to know that you're creating an and checker. And since we know the implementation of and checker, you know that it takes in, where is it? Regardless of what you wrote here, right? You know that your and checker takes in two checker objects and runs except on it, returns true if they both return true, right? Not checker returns true if they're both not true. So we're looking for two not trues, right? So we create two not true or not checkers. We plug them into the and checker, and that's going to return true. That except method is going to return true if they're both not true. Questions? Okay. If you're not immediately blown away by how tricky that question is, and you find that you have some questions on it later, you got a couple of days, I encourage you to come talk to me. So that is it for Form 3. Form 4. Let's see. We have a music website that keeps track of downloaded music. This was one that a lot of people got right on the AP exam itself, like the big AP exam. I think that was 2014. Okay. Music website that keeps track of downloaded music. This one is, the algorithm in this one is almost identical to the toy store one that we did. And that's a lot of reason for that lab is to handle questions like this. So we have a download info object that it gives you, and it shows you like the way the basic class structure works. And your job in, and then it gives you it also gives you the basic structure of music downloads class. So there's a whole class here that we're obviously going to deal with objects of. And we're going to write a method called get download info, which is from music downloads. And I think that is here to be implemented in part A. Let's see. This is very similar to get that toy. Remember the get that toy method where it looks up, it's going to look up a song by name. And if our list of songs already contains that name, then we're going to add one to the count of that one. Otherwise, we're going to create a new one and add it to the list. So if you think about this, I'm trying to find my. So if you think about this one, all we have to do is remember that we have this instance variable download list. So we take in a string title and we loop through the download list. On each object in the download list, we're going to get the title. And if that title equals the title that we're bringing in that we're looking for, then we're going to return that object, and otherwise we're going to return null. Does that look familiar to most? Hopefully that looks familiar to everybody. Okay. So that's really part A should be, if you were paying attention during that section, part A should be pretty straightforward. Not necessarily easy, but simple, solvable solution. Music downloads method. Update the downloads, which takes a list of titles and updates the download list either by, so if you read this correctly, either by incrementing the download count or by adding a new object to the title, right? So remember that you have to use what you've already written. So this decision right here, this either or, that we've already developed the ability to make that decision. We've already written that functionality into our code. So we're going to be using that in the final solution. So we're assuming that all this stuff is the case, and none of this, I don't know that you really need any of the rest of this to solve the problem, because we've already done this. The only thing we do is we need to create a loop in a list of song titles, right? So we're taking in a list of titles, right, in string form, and we're checking each one of those to see if they're on the list. And then if not, we're adding it to the list. So we're going to say, we're going to go through each title in our list of titles. We're going to say, if our download, if we get the title of each of those downloads, right? So title. So we're going to use our existing get download info method, right? So remember that takes in a title, sees if it's on the list, right? And then returns null or the actual object itself otherwise, right? So we just create a new download info object, and we use get download info to return the object. And it's going to be either equal to null or an object, right? If it's null, we have to add a new one to the list with that title. Otherwise, we're just incrementing the number of times that it's downloading. The thing that makes this complicated is we have to understand that our class itself has another method that says increment times downloaded. So you have to know that you're adding 1 to the number of times downloaded using what you already have. So this one, the actual algorithm itself is not complicated. Keeping track of all of the pre-written code is definitely the issue there. Questions on that one? All right. Question 2. Let's see. We're going to, we have an interface and a set of classes. And it's just items that are available for purchase. For whatever reason, split them up into taxable and non-taxable. And the difference would be that you have list price. You're adding tax rate to the purchase price. So the purchase price is in probably every POS system is going to be cost plus whatever your margin you want to make on that item, right? And if it's a taxable item, you have to add tax in there too to make it make the purchase price. We already have the two items. The interface is written for us. We have an incomplete taxable item class. We're going to write the purchase price method on the taxable item. Should be pretty easy. Or actually, purchase price, not that it's just plus tax, right? So if you read carefully, we're just returning the list price, which we already have that method for, right? Plus the tax, whatever our taxes are. And part B, slightly more, part B is slightly more tricky. We're going to create a class called vehicle that's a taxable item. It has two parts. It has dealer cost and dealer markup. The list price, different from the purchase price, right? List price is the sum of dealer cost and the dealer markup. Pretty simple. What it costs you to get the car, how much money do you want to make off the car? There's your list price. In order to get the purchase price, you have to add tax to that. So that part, that it should be pretty simple from there. It's just figuring out where am I supposed to get stuff from, right? So I have instance variables for dealer cost and dealer market. I think it might have given you that. List price, dealer cost, dealer markup. Class should have so we have a constructor that takes dealer markup and dealer cost and the tax rate as parameters. Pretty simple. Instance variables. The rate is the tax rate is something that we inherited from the super. So that's pretty tricky. Like if you could potentially lose points here by not understanding that a taxable item, right, has a rate because it extends. Okay, so because a taxable item, I think here, right, has tax rate, that's something that we're already inheriting. So we don't need that as an instance variable here. You just call super and plug in the rate. Because I think they made that. Interesting. Super. Does that take in the rate as, yeah. So it takes in the constructor, it takes in the rate. So we just call super and put in the rate. Well, we're taking in cost markup. So we have instance variables for those. We set them up in the constructor. We pass rate to the super. Now we have everything we need to get the list price. List price is cost plus markup. Does it say to do any of that? Taxable item is the list price plus the tax on the item. Create vehicle. Vehicle has two parts to this: list price, dealer cost, and dealer markup. So list price is dealer cost plus dealer markup. I should have a constructor, tax rate. Did we do everything? That list price. So it would already have, based on here. So this one's tricky because we have to keep track of, okay, well, it's a taxable item, so it's going to have purchase price, right? But purchase price is already implemented properly, right? Because it runs get list price. So the tricky part would be with this one that you don't need to rewrite any of this. I'd be concerned about the purchase price, but the reality is it's already there, and since it already has access to everything, because all it's doing is running get list price, so I can run get list price, right? No matter what kind of an object I use to extend this, I still am running get list price on it. So whatever algorithm I could have, I could have a 100-page algorithm here. As long as I'm returning a get list price, it's still going to add the tax rate and proceed as normal. So this doesn't have to change, and I don't have to update it in there. That's the trickiest part about the whole question. Questions on that one? All right, let's go to 3. I think this one's fairly simple. We have an incomplete class that stores information about a customer, a name and unique ID. Customers are sorted alphabetically by name. 2 or more customers have the same name. They have an ID number that can help sort them out as well. So I think the first part, we're going to write the constructor. Or no, it's not going to show you the constructor. So we're going to compare customer. What it's going to do, we're going to compare each customer to whatever the input customer object is. And if the 2 names are the same, they're going to be ordered by ID number, right? So it's going to check, hey, can I sort these by name? No, then I'm going to check the ID number and see which one comes later in the alphabet or whatever. So it'll see which one is. So what this is going to do, it's going to compare the 2 customer objects lexicographically, which means which one would come first if you put that information into a dictionary. It returns a negative number if the input comes before. So if the left value comes before the right value, that comparison returns a negative number. If the left value comes after the right value in the dictionary, it's going to return a positive number. So negative is back, positive is forward. So you can see a table, see examples of things. I'm not sure how much that represents what you're doing. Part A, which customer comes first in the alphabet? So we're going to find the difference. We're going to get name, and we're going to compare. We're going to use the compare to method. If there's no difference, right? If they're the exact same name, then we're going to figure out which ID is less or more. So we just subtract one from the other and we return the distance. If you get a negative number here, right, that means that the distance is going to the difference is going to be negative, and you're basically saying that customer, the input customer is, or the existing customer comes before. So in this case, we're inputting a customer other, right? In this case, our current customer object is on the left and the other is on the right. So if our current customer object has a name that comes before, we're going to return a negative number. If they have the exact same name, it's going to, or if our current customer object has a name that comes after the other that we're pulling in, it's going to return a positive number. If they have the same name, it's going to figure out which one has the lower ID number and then sort it based on that. Questions there? Okay. So we're maintaining a customer list, and we're merging prefixes, which means taking in two lists. Let's see. Prefix merge, which takes 3 array parameters. First 2 arrays, list 1 and list 2, represent existing customer lists. It's possible that some customers are in both arrays. So we're trying to merge the list and find, and you want the list to have all the unique customers, right? So if one customer is in both lists, like Burton, he would only appear once in result. So it's a list merge. The only tricky part about this one that's kind of confusing, and I don't think they do that great of a job of explaining it, is that the result list is less than the number of unique customers that you have between these two lists. So not all of them are actually going to get stored in the list. I don't think that's doesn't seem exactly necessary to write the method, but for whatever reason, they kind of confuse the situation here by the fact that this result array is way smaller than what it would be if you tried to contain all the unique identities in both of those lists. But the reality is, all we have to do is write the prefix merge method. So again, fairly straightforward. So we're gonna go through. What does it want? It wants to fills result with the merged values from the list. Doesn't want it to contain duplicates, and this one, list 1 and 2. Make sure the other list is not modified and no duplicates, basically. So, and do whatever you want as long as it contains all the unique ones and no duplicates. So we have okay, so we create 2 variables. This one's a little bit tricky because we have 3 arrays that we need to keep track of, which means 3 iterators, right? So we start with I and j, set them both equal to 0, and then we have a for loop that starts with k equal to 0. Customer 1 is list 1, right, at position I. Customer 2 is list 2 at position j. What we're going to do is we're going to compare the customers to each other, find out if that number is positive or negative. So we're going to compare customer 1 to customer 2. Basically, this says if that's a negative number, that means C1 comes before C2. Then we're going to add C1 to K, or to result at position K, which at this point is at 0, right? If we take the value at position I and put it into the array, we're advancing the I forward. If we're taking J, right, Same exact principle. If we're actually if the result if C2 at J was the one that was less, we would be adding that to result, and then we'd be moving J forward. So if we reach something, if we reach a position in the array and you're like, that's the value I'm adding to results, then you need to skip to the next one. But if you didn't add that, if you didn't take that value out of C2 and you're like, but you checked it, you don't want to advance C forward, right? You don't want to advance C2 forward. You want to stay on that value until you're using it for something, until you find its proper or correct order in the list. Okay? Otherwise, if C1 and C2 are the same, just add C1. And then we can move forward in both lists. Is it collecting ID numbers? No. So that's the tricky part here. If one's not greater than the other, that means they have the same name, right? So why wouldn't we just pick one? It doesn't matter which one we use here. We just set result at K to that name value, and then we found, we don't want to use that identity again, so we're just going to advance both forward and skip past. Question? Come on, guys. I know there's got to be at least a couple of different aspects of that are going to be confusing. Please make sure you take a look and decide. You still have plenty of time to come talk to me about whatever. So question 4 on this one, pretty simple. We have menu items. Each one has a name and price. We have a program that allows you to put 3 of them together and get a discount. So we're writing the complete class, including a constructor, right? Trio is basically a menu item that gives you, so we see all the other menu items and how they work, and it has an interface, so we want to make sure we have a method get name that returns a string, method get price that returns a double. So that's the only part that we need to implement. Other than that, we have a simple constructor. Right? We have to have a sandwich, a salad, and a drink. And they have to be in this order. I think it gives you, it wants to be really sure here that you put those things in the right order, so you don't get compile time errors. So it wants sandwich, salad, drink in that order. Read the constructor. We have get name, and it returns all 3 of the names because there's 3 items, right? So we run get name on all of them, and it returns a string. Get price is the price of the entire thing. What's different about this one is that it's asking you to, in the trio, you get one thing for free, right? You get the item with the, so we're finding the smallest price, right? And so you can use math.min, you can use a series of if statements. Whoops. Why? Okay, so you don't have to use math.min there. If you didn't know how to use math.min, you could use series of ifs for, or how would I do that? If it would just be a series of if statements, right? If price 1 greater than or less than price 2, blah, 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 smallest equals price 1, so on and so forth. It'd take like 3 if statements, but you could do that there. Basically, you're just finding the minimum price, right? The thing that's the smallest price, and then your new total price is going to be all of these added together minus whatever the smallest price is. Okay? Questions on that one? Okay, I think most of those in 4 are pretty straightforward, except for that one that was kind of big. But please let me know if you have questions on any of that stuff.